Technically speaking, nothing interesting here. So what the heck is a tuple? It means list. For example, I love you is not the same as you love me because the order matters. So that means order is important in tuple. 3 apple, 4 orange is different from 4 apple and 3 orange. If we have more than one thing, we call them ordered pair. Ordered pair. What does it mean? I have an XY plane. This point is 0, 2. This point is 2, 0. X is 2, Y is 0. They are different points. You cannot swap the order. So this is called order. It's the same as I love you is not the same as you love me. But if I only have one thing, order doesn't matter. But if I have 2 things or 3 things or 4 things, they matter. And then we just basically call this thing n tuple. So if we have 2 things, we call it 2 tuple. Or people just call it ordered pair. If you have, let's say, this is your function with 2 input, you swap the x and y, suddenly output becomes very different. So the order is important. And you may wonder, who the heck care about this? As I already put across here. Yes, actually don't care. But here's the reason. Because everything we talk about will be tuple. For example, a group, you don't know what the heck is it, is a tuple. A graph theory graph is also tuple. Anything you study in physics in high school is 4 tuple. Computer is a 7 tuple of 7 sets. And if all these things are satisfied, that thing is a computer. So that means what is Turing machine? Turing machine is a set, but inside this set have 7 stuff, which each stuff is also a set. And what's a vector? Vector is also a tuple. You write 1, 0, it's an ordered pair because this is not the same as 0 and 1. So the order is important. And this is vector in 2-dimensional space. And if I have 3 number, then this is 3-dimensional vector. And you can keep going on, then you have n-dimensional vector. Now, we have the following thing. This is called Cartesian product. I just told you what is addition, right? Now what's multiplication? A times B is not this, okay? Do not say no. I'm saying the Cartesian product is all the ordered pair AB. That means I put AB like this as a vector, and then I consider all the possible case like this, and I call this Cartesian product. This is the definition of Cartesian product. What about this? This is something else. We don't talk about it. And we will write this notation. So R is what? A set of all the x that, okay, x is real, okay, for example, it's rational, it's also irrational, it's integer, is integer including 0, blah, 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 right? Then what about R squared? It will be all the x, y such that x is R, y is R. Okay, R squared is just R, Cartesian product R. What about R3? It's just R, Cartesian product R, Cartesian product R. So this is the meaning. What I just said here is just a bunch of set theory thing. They link to geometry. This means 2D plane. This means 3D space. I have a XY plane. Suppose I draw XY like this. This is X, this is Y. Then this whole space, I can go forever. I didn't draw the whole space. I just draw a part of it. This is R2. What about R3? I have the third axis. Then this is whole space. This is R3. And then what about a simple set example? I have D, E, F, and E, F, G. Then what is A Cartesian product B? It will be with this bunch of stuff. Why? All the possible A, B in here, right? So I pick D, multiply E, okay, here. I pick D, multiply F here. I pick D, multiply G here. And then I just do the same. I will have 9 stuff. You do the same thing for B times A, you will find that they are not the same. For example, DE is not an ED, so therefore it's not the same thing. They both have, let's say, EE or FF. EE, FF. But something here do not belong to here. So they do not fit what? Subset definition. If they are not the subset of each other, they are not equal. So I can just write this. The real deal is when we have Cartesian product, we suddenly have something called relation. This is the reason why you need to study relation. Because if some of you in the future become something called a database engineer, then you need to know this. So what the heck is this? Suppose 3 smaller than 5. Everybody know. Is 7 smaller than 5? No. 7 is larger than 5, right? So I call this a relation. What the heck? So I have 3 and 5. So suppose I have natural number. So start with 0. 0, 1, 2, 3, 4, 5. Now I also have another natural number set. I draw it vertically. 0, 1, 2, 3, 4, 5. Now I have this is 0 smaller than 0 because they include equal, so it is true. So yes. Is 0 smaller than 1? Yes. Is 0 smaller than 2? Yes. So actually a bunch of yes here. Okay. Is 1 smaller than 0? No. Is 1 smaller than 1? Yes. So I have a bunch of yes here. Now you should see the pattern. Okay. Is 2 smaller than 0? No. Is 2 smaller than 1? No. So I have this. So if I keep doing this, okay, I will get what? I will get something that looks like a triangle. If I keep doing it, this thing is what? Is a subset of n Cartesian product n, right? This funny subset tells me for this thing, which is basically the whole box, some guy belong to this whole box. This is a special subset. We call it a relation. Okay, that means something belong to a set which is a what? Cartesian product, fulfilling some special rule, such as smaller than. Okay, what happens if I have greater than? If I have greater than, let's say my greater than is green arrow, then my greater than will be this part. And importantly, they share the same diagonal. Okay? Then here's a funny question. Suppose I have a Cartesian product of n times n. Picture is like this. Find the relation, give me the shape that looks like this. If you can find the relation, that means 3 something 4 will be here. Find this something. Then it will be very useful, because sometimes I want to find this thing such that something is true, something is not true. Maybe this is some computer programming requirement. Then this is a reason why you want to study this. English relation. Peter like David. So it's not the same as David like Peter, because it's ordered pair. I love you is not the same as you love me, right? Okay. So the order is important. And because of that, we will have something called graph. Later on, you will see a bunch of pictures. Okay, later, but now let's talk about the relationship. So what the heck is relationship? This is the definition. We call it binary relationship, means we have two stuff. A, in a set A, we work on what? Cartesian product. And we write if x and y are related by the symbol r. And if x and y are not related by the symbol r, we just put a cross here. So here is an example. I have a set 1, 2, 3, 4, 5. It's called A. Let me define the R is equality. Then what is the relationship on A? This. Because is 1 equal to 1? Yes. Is 1 equal to 2? No. Is 1 equal to 3? No. Is 1 equal to 4? No. Is 1 equal to 5? No. So I have 1, 1. So again, draw a picture. I have 1, 2, 3, 4, 5, right? So I have 1, 2, 3, 4, 5. I have 1, 2, 3, 4, 5. Because I'm talking about binary relationships, so always draw a square. You can find out this is the first guy, this is the second guy. Is 1 equal to 1? Yes. So I draw a black dot, means 1. Is now all the rest is not equal, so I don't draw anything. For 2, is 2 equal to 1? No. Is 2 equal to 2? Yes. So I have a dot here. Now we should see that it's basically this. So this bunch of stuff is the relationship. And what are this bunch of stuff? This is the picture, not the solution, right? Relationship is a subset of Cartesian product. So this corresponds to this 1, 1, which is this guy. This 2, 2, which is this guy. This 3, 3 is this guy, and so on. I have a set 1, 2, 3, 4, and my relationship is smaller than. Now what is the set? It will be 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. Now here's a crazy one. I have a set 1, 2. My relationship is subset. Find the relationship on all the possible subset of A. That means power set. So first I list what is power set. And then what? The relationship will be, what the heck is this? So is 0 a subset of nothing? Yes. Is nothing subset of this? Nothing is subset of anything. So nothing is always subset of this. So these are true. Is 1 a subset of this? A set is subset of itself. So true. Is 1 a subset of this? Yes, because 1 exists inside here. Is 1 subset of 2? No, there's no 1 here. Okay. This is again 2 is subset of itself. 2 exists here. So okay. 1, 2 and 1, 2 are the same thing. So subset of itself. So this big chunk of thing is a relationship. This is the part that makes set theory complicated. Okay, because now I mixed up so many things. So that's all for today. I will just stop at here.